Okay, this is question number 14, Pathfinder, Newton's laws of motion, MCQ. A light uniform spring is tied between the ceiling and the floor, keeping the spring vertical as shown in the figure. A bead of finite mass is glued at a distance L from the upper end of the spring and then allowed to move gradually downwards. The bead shifts a distance y to come in equilibrium. This experiment is repeated for different values of L. Which of the following graphs show the best dependence of y on L? And these are the graphs. Okay, suppose bead is placed at this red line at this position, which is at a distance L from upper end and is released. Suppose the upper part of spring has a spring constant K1 while the lower part has a spring constant K2. As we have earlier derived in previous video, we know that K1 into length of upper part will be equal to K2 into length of lower part, and that will be equal to K into total length of spring. So K into length of every part of spring is same as K into L of total spring. So that we'll be using here. So K1 into L is K of total spring into length of total spring. So that gives K1. And similarly, we can find K2. And when the bead moves, both these springs exert force in same direction. So both these springs have an effective K of K1 plus K2. So simply add these Ks and we get the effective value of K. Now where the bead comes in equilibrium, there mg will be balanced by effective K into y. So we have this expression, y is the displacement of bead. And from here we can see that y depends on this quantity L minus L into small l, and rest of the quantities are constant. So we have this expression, and we have to draw graph of this expression and see which of the given options is correct. So let's see how to draw graph of this. So we have this expression, y is equal to some constant into this. Now differentiate to find at what value of L this y becomes maximum, and for that put dy by dl is equal to 0 to find L is equal to L by 2. So our graph will have y equal to 0 when small l is 0, so it will pass through origin, and it will again be y will again be 0 at small l equal to capital L. So we have a quadratic graph, a curved graph, which becomes 0 at origin and at L equal to capital L, and it becomes maximum or minimum at small l equal to L by 2. Obviously it will be maximum because y cannot be negative, and since its value is becoming 0 at two positions, so in between those two positions, since y cannot be negative, it will have to be positive, and therefore y will be a maximum. Otherwise you can double differentiate the expression and see that it is coming out negative, which implies a maximum. So option D has the correct graph. It is y 0 at L equal to 0. It is equal to again 0 at L equal to capital L, and somewhere in between it's becoming maximum, that is at L equal to L by 2. So option D is correct.